Hello class, in this video I'm going to show you how to identify linear functions and linear equations. So a linear equation has the form y equals mx plus b, where m and b are constant numbers. That's just the way a linear equation looks. Linear comes from the word line. And so the graph of a linear equation, the graph of a linear function, they're lines. Remember that vertical line test? So a vertical line would not be a function. That's why the word linear comes from the word line, but we gotta make sure that it's not a vertical line, because vertical lines are not functions. A linear function, the graph of a linear function is also a line. And some of the assignments, some of the questions that you're gonna be asked to do from this section would be something as simple as the following. Which of these graphs is linear? Just know that the linear functions are lines. So the first one, we know that this function is linear simply because we have a line. It's supposed to be a straight line, but there you go. So this is a function, a linear function, because it's a line. This is a function. It is a function, but it's not linear. So this is an example of a non-linear function. So just be aware, again, it's any line except for a vertical line. A vertical line, remember, it's up and down like this. So a graph that looks like this is not even a function to start with, and it's not considered linear, of course. So one of the things that we want to memorize about linear functions is that they have a constant rate of change. The rate at which they grow or decay or decrease is constant, is the same. That's what makes the graph a line, because if you go 1 unit to the right and 1 up, 1 unit to the right, 1 up, 1 unit to the right, 1 up, it's going to show the same. It has the same rate of change. It's going to turn into a line. So that's what that means by a constant rate. Let's take a look at an example here. Does the chart or the table represent a linear or non-linear function? So all we have to do is consider that a constant rate of change means that the x has to change from one step to the next step at the same rate. So for example, here, if you're going to go from 2 to 4, you have to add 2. From 4 to 6, you have to add 2. And from 6 to 8, you have to add 2. But that doesn't make it a linear function. We have to take a look at the y. If you go from 9 to 6, you're practically subtracting 3. From 6 to 3, you're subtracting 3. And from 3 to 0, you subtract 3. Now, this is a linear function because there's a constant rate of change. Do you see that? The x's and the y's are changing at the same rate. Or I should say, from step to step, the rate, the difference in the x's is the same, and from step to step, the difference in the y's is the same. So we say this is linear because it has a constant rate of change. The next one, however, if you look at it, is you have to add 5, and add 5. So people would say that this is linear, but we have to take a look at the y. Look, we have plus 3, plus 5, and plus 7. So this is non-linear because it doesn't have a constant rate of change. Okay, then we take a look at the next one. Of course, we have to add 1, and add 1. And then here, to go from -1 to -1, we add 0. We add 0, and we add 0. So even though it looks kind of weird, kind of strange, it's still a linear function because the rate of change is constant. So this is linear. Okay, and then just to wrap this up, this short lesson, we have to know that there's multiple ways of writing or representing a linear function. In an equation, we know this is linear because x and y have no exponents. So this is a linear function. In a line, we know this is a linear function because we obviously see a line. And in a table, we could check for a constant rate of change and verify that it is linear. So there's multiple representations for a linear function. Just be aware that you can represent 3 equations as long as you don't see exponents on the x or the y. It's just an x and a y with no exponents or no square roots or anything like that. Just clean variables like this. Okay, this concludes the lesson. Please keep reviewing your notes.